All right, so we worked to have a way of phrasing this chain rule for derivatives in a form that was sort of maybe wordy, but was representative of what was going on, which is to say that, of course, we know that dy over dx is just dy over du times du over dx. That's nothing too fancy to say, but what we noticed was that whenever we went through the act of taking the derivative, this dy over du, this first factor here, was really nothing more than just taking the derivative of the outside function, leaving the inside function alone. Whenever you look at this derivative that we computed for cosine of x cubed plus 7x, the first factor was just minus sine of whatever was inside. We left the inside function alone, taking the derivative of the outside function, because of course the derivative of cosine is negative sine. But that wasn't the whole story, right? This factor, this first factor, is not the only factor that shows up in the derivative. The dy over du factor is not the only factor that's needed to get dy over dx. You also need the du over dx term. Where did that come from? That came from taking the derivative of the inside function. And what was the inside function? The inside function in the example that we went through was the x cubed plus 7x. That derivative was 3x squared plus 7. And the derivative of the inside function was then the second factor that resulted. And then you say, okay, well, this is cool and fine and well and good, but what I really want to get to is a way of phrasing the chain rule in a form other than this. Because actually most of the forms of the derivative that we've written out haven't been in this form in terms of like remembering the rule. So here's what I'm going to do. We're going to say, okay, let's try to take the derivative of a function that is itself a composition of functions. Now, how does composition always show up? Well, you always have some function that's been put inside some other function. So rather than me just writing f of x here, what I'm going to do is write f of u. Here, u is the thing that's been put inside our function. U is the x cubed plus 7x. U is whatever the inside function is. So if we write this out here and take the derivative of fu, nothing personal there, obviously, this is just a function of u, we first need to take the derivative of the outside function, leaving the inside function alone. So we're going to leave the u alone and just take the derivative of the outside function. That would be then f prime of u. Note this is like our factor here. The f function would be our cosine, the u function would be what's inside. We take the derivative of our cosine function, leaving our inside function alone. That's our f prime u, but that's not the whole story, right? Because we also have to take the derivative of the inside function. What is the inside function? That's our u, and the derivative of that would be u prime. So here is a new way to express the chain rule. Look at your original function as f of u. First take the derivative of what's on the outside, leaving the u alone, then take the derivative of what's inside. Let's do an example to see this new idea in action. So what if we had the expression, oh, I don't know, tangent of e to the x plus 5x squared. Let's say this is our original function, and we want to find its derivative. Totally doable. Because see, here's the thing. We need to think of our original function as the tangent function with something inside of it. So the first thing we're going to do is leave that something inside of it unaltered, e to the x plus 5x squared. And all we're going to do then is take the derivative of the function on the outside. And you know the derivative of the tangent function is secant squared, so secant squared would be its derivative. But this term here is only your f prime of u factor. You still need to take the derivative of the piece that's on the inside, because the derivative of fu is f prime u times u prime. So what is u prime? U prime is the derivative of what's inside. And what's the derivative of what's inside? Well, the derivative of e to the x is e to the x. and the derivative of 5x squared is 10x. But the long story short is our original function, which took the form of fu, now when we take the derivative is f prime of u times u prime, and it is precisely this. Now here's the thing to think about. And here's what sort of the big takeaway is from looking at the derivative in this form. When we start to look at the derivative through the lens of fu, derivative f prime u times u prime. I again apologize for the fu, that sounds horrible, but I mean, it just is what the expression is. The long story short is, actually, this makes a relatively long story of taking the chain rule a fairly short operation. Because what we ended up doing was taking a process that, using the dy over du and du over x terminology, took multiple steps in cobbling things together, and it sort of cobbles things together in one single swoop. So you leave the inside function alone, take the derivative of what's on the outside, and then multiply by the derivative of what's on the inside. And that makes quick work of what otherwise sometimes feels like a long drawn-out process, and man, it allows taking the derivative of chain rule expressions very nice and relatively pleasant.